So we're over here on page 5 of your notes because we're going to go back to the other parts, but we wanted a shorter one today. So that's what we're going to do. We are not going to get out the protractors and be drawing angles because for our purposes today, we don't need that portion of things. I wish we had time, but we don't. So, on page 5, we are going to start with degrees and radians. You're like, what the? Radians? Radians is trig language for degrees. Okay? It uses its own little foreign language here. So, it's based on the length of an arc around the circle. In other words, if you looked at this like a pizza, you're looking at the crust here on the outside, kind of is what you're looking at. And the radian measure would be the slice of pizza as a whole. So, here's the two things we got to keep track of, which is why we're going to write this here. 360 degrees is all the way around a circle. Okay? When we speak in radian, 360 degrees is 2 pi radians. Okay? Not 3.14 pi. Not that one. This is a different way of measuring that. And then since 180 is half of 360, half of 2 pi would be pi radians. Normal pi, but it's still not 3.14. We're using it for a different thing. In this case, it's 180 degrees. Bless you.
Why?
So, to be able, for some of the formulas you would use in trig, you have to use radian measures. So, in order to change a degree measure into radians, we are going to multiply it times pi over 180. You're like, okay, why pi over 180? Since pi is the radian version of 180 degrees, you're basically dividing by 180 over 180. You're not changing the value at all. And so for us, when we multiply straight across, we end up with 30 pi over 180. Now here's the part we got to remember. We're not going to put the pi in the calculator, okay? The only thing we need to do when we're going to reduce this is take the 30 divided by 180, leave the pi alone, math, enter, enter, which would be 1 pi over 6, or just plain old pi over 6. That's all you're doing when you're converting between degrees and radians. So anytime these degrees are here, positive, negative, doesn't matter. If you want to go radian, we do pi over 180 because that way the degrees cancel. 150 divided by 180, math, enter, enter, is 5/6 or 5 pi over 6. No tricks. Nothing crazy. Again, the degrees cancel. You're like, wait, that says negative 220. There's negative angles? There certainly is. It's a thing. If we get some extra time sometime, I will show you how we can have a negative angle. So if it starts with a the negative has to be part of my answer. So if we're going to radians, there should always be a pi in your answer. No. No, when we're doing radians, we're doing exact values. And if you tried to do it in a decimal, the calculator is going to use pi as 3.14, and that's not the pi we're using. Yep, we're not doing all that. So if you're in radian, however, and you want to go back to degrees, we're going to take this fraction we've been using, and we're going to flip it over. Well, why the heck are we flipping it? Because then the pi's will cancel. And then you can either multiply straight across. So 4 times 180 is 720 divided by 3. And yes, we need to simplify. 720 divided by 3 is 240 degrees. Off and run it. Yes. Yes. Final exam stuff is next week, and I will be getting you final exam materials tomorrow. God, I always love the play-by-play in here. All right. So -5, don't lose your negative, times 180, -900 divided by 36, -25 degrees. Okay? It's a degree to radian, not a bad thing. Not a bad thing.
Is that it for the whole thing?
No, don't slow down. It's just
No. Can you hold for a second, please?
Okay, so between degree and radian.
So the pi's cancel and there's normal multiplying?
Yeah, because like anything, when we're trying to multiply with fractions and they're right next to each other, if you have that exact same thing in the numerator and denominator, you always can cancel those. That's why up here the degrees cancel and just get me to pi, and that's why the pi's or our radian measures cancel here to get me to the degrees. Okay? So the other play that we're going to do today, and the last one, I told you this is going to be short. So the last piece for today is on the back something called a coterminal angle. Okay, so what does coterminal mean? Coterminal means we're adding or subtracting 360 degrees. We're doing a full circle, a full rotation. Or if we're in radian speak, we're doing plus or minus. Coterminal means full circle. It means if I started somewhere with an angle and I did a full circle and ended up back at the same place, what would the degree measure end up being there? So, what we're going to do with our examples here is we're going to come up with a positive coterminal angle, and we're going to come up with a negative one. So here's how this works. With degrees, easy peasy. You're going to take the angle measure they give you.
Oh, it's not like a plus or minus. It's plus.
No, we're going to do two separate ones because they're not going to be the same number. So if I take 65 and I add 360, 425 degrees is a positive angle, so it would be positive, and it's 360 degrees more, so it's coterminal. Yeah. So it's like if you were to have, a 65 degree angle, so like let's say this is 65 degrees, and I rotated this all the way around in a circle. In other words, I added another 360 degrees and came back to the beginning. That same angle would now be 425 degrees.
Okay, so now we're gonna take away 360.
Right. So now what we're going to do on the negative is we're going to do 65 minus 360. But they'd still all end at the same place, which is kind of weird. But the one thing you've got to remember with these is, if you're asked for one positive and one negative, they actually have to be positive and negative. And you're like, well, duh, Hardy. Okay. All you people out there thinking, duh, wait till we see this one. I should have kept quiet and seen if...
540 plus 360.
That's kind of large. 900. Now, The negative.
That's only
Is 180 negative?
no.
No. So if it's not negative, we need to subtract 360 again. Positives have to be positive, negatives have to be negative. If you have to do it more than once, you do. That's just how this works. It goes that way. But now,
We need to get degrees. So pi or no, 180 over pi.
okay, I'm going to make a suggestion because I have people want to try what you're thinking and it ends up backfiring. So the question is, can I turn this into degrees and then do my plus or minus 360 thing? You could, but the other rule in math is if it starts in radians, it must end in radians. So if you do that,
You have to convert that.
right, you'd have to go radians to degrees.
So you'd have to do the 180 over pi to begin, and then at the end do pi over 180.
Correct. So that's a lot, but I'm going to show you both ways because some people actually like that better. So let's say we do this one, but we're going to do it classic way here. So for my positive, I'm going to do 13 pi over 18 plus 2 pi. You're like, ugh. So how do I do that? Don't put the pi in the calculator. Okay, so 13 divided by 18, in parentheses, plus 2. We don't want decimals. Math enter. You're like, whoa. Is that right? It is. It says 49 over 18, and you put the pi back in. That's what your coterminal angle would be, positive in pi.
But like, where are we getting numbers from, Mr. Harding?
Where are we getting numbers from?
I feel like this is so made up.
This is not made up. It actually works. It actually works pretty well. See, I'm a logical type, and to see this stuff, this all makes more sense than a lot of the things that I tend to see. So let's kind of play that one more time and see if it works here. So, oops, got to do my parentheses, though. 13 divided by 18, minus 2. Math, enter. Oh, good, it came out negative. Negative 23 over 18. Don't forget the pi. Don't forget the pi. Don't do it. So for any of these, don't let the weird numbers throw you off. It's the exact same process. Just that one hint of reminding yourself, no pi until the end. So 32 pi over 9. For those of you that like to do speed demon-y little shortcut stuff, let me teach you one trick here quick. Whenever you're doing these, since you're adding 2 pi, if you look at these, whatever your denominator is, so it's like 9. 9 times 2 is 18. 18 plus 14 is 32. Like if you're not wanting to go to the calculator, that's a way you can do it in your head. Denominator times 2 and then add it to your numerator. That'll work every time.
Are you positive?
Look back over here. 18 times 2 is 36. 36 plus 13 is 49. It'll work.
Okay, I trust you, Mr. Harding.
Now, subtraction, you have to be a little more careful, but it still works. So if I do 14 pi over 9 minus 2 pi, 9 times...
You gotta keep it negative.
9 times 2 is 18, but it's negative. So 14 minus 18 is negative 4. But let's see if Hardy's crazy. I'll gamble. 14 divided by 9 minus 2, math, enter, negative 4/9. Yay! So that's where we're cutting things off for today.
Are you a gambler, Mr. Hardy?
Not as much as I used to be. So, with this, if I can get to my practice, which has disappeared. Seriously, where is my practice? Did it get stuck in my packet? No. Hang on. Steal it from over here. All right, we're going to be on page 5. Let me jot down what we're doing here. So the directions are kind of weird, so stick with me. 1 through 12 all. 13 to 18 coterminal only. We did not do reference angles. We are not going to be doing reference angles. I'll save that for if you take the actual trig class after this. No? Some of you are, that's good. You got a 50-50 shot of being stuck with me again next year then.
Oh yeah, you're ahead of me.
They changed me around. So that's where we're heading.